Welcome to our lecture online, and here we're going to talk about integration. And of course, integration is a huge topic in calculus, and it's going to take many, many lessons to get through all this, but you got to start somewhere, and this is our beginning. We're going to learn how to integrate a constant, and here's the general format of integrating a constant. Let's say that a is a constant, and the x is the differential with respect to the variable x. And the rule always is that you can move the constant outside the integral sign, so this can be written as a times the integral of dx, and by definition, the integral of dx is equal to x plus a constant of integration. So this is equal to a times x plus some constant of integration, I'll call that c1, and then when you multiply a times x and a times c1, this gives you ax plus a times c1, and you can just combine these two. Since both of these are constants, you can write this as ax plus c, and that's the integral form of the constant a times dx. So to illustrate that with some examples, here we go. So we have the integral of 5 dx, so this is equal to 5 times the integral of dx, and by definition the integral of dx is x plus a constant multiplied times 5, so we get 5 times x plus the constant c. C is always what they call the constant of integration. Why is that constant there, by the way? Well, it turns out if you take the derivative of this, the derivative of 5x gives you 5, and the derivative of c gives you 0, and so the constant disappears when you take the derivative. And integrating is what they call the antiderivative. So when you don't know what the value of the constant was when you took the derivative, when you then go the other way, you just have to say, well, there was some constant there, perhaps, doesn't have to be. And since we don't know what it is, we'll just write it as the constant c. That's where that comes from. Here, our second example, of course, pi is a constant, so we can move that outside integral sign. So it's equal to minus pi times the integral of dy. And so this then becomes equal to minus pi times y plus the constant of integration. And finally, let's say that a and b are two constants, are added together. We can move that outside integral sign, so this can be written as a plus b times the integral of dz. And of course, the integral of dz is z plus a constant, so this becomes a plus b times the variable z plus a constant of integration. And that's how you integrate a constant. And then here we are on our next step of many, many steps on how to do integration. And the next rule is how do we integrate a variable raised to a power. For example, x to the n power, n could be any number. And so the rule is that when you integrate, you add 1 to the exponent and divide that by the new exponent and add a constant of integration. So for example, if you have x cubed, then when we integrate that, this becomes x to the third plus 1. We add 1 and then we divide that by 3 plus 1. All right, so let's try that. Let's try that on these examples. So this would then become x to the 3 plus 1 divided by 3 plus 1 plus the constant of integration. Of course, this becomes x to the 4th power divided by 4 plus a constant of integration. And that's how you integrate something like that. Of course, you can now see that you don't necessarily have to write this. You could probably just simply go x to the 4th divided by 4 and just go straight from this step to this step. All right. Here we have another example. Pi is a number, so y raised to the pi power dy. The integral of that is equal to y to the pi plus 1 divided by pi plus 1. So here we cannot readily add 1 to pi, and so we're just simply going to write like that. And of course, don't forget the constant of integration. All right, in our last example, you say, well, wow, what do I do here? Z to the minus 5, but the rule is no different here. It doesn't matter what the exponent is. Always add 1 to the exponent, divided by a new exponent. So to illustrate, this is equal to, the integral, when we integrate, the integral sign, of course, drops off. And then we get z to the minus 5 plus 1. I'll just go ahead and put the intermediate step here so you can see how it's done. Divided by minus 5 plus 1. And so this, don't forget the constant of integration, plus c. And so this becomes z to the minus 4 power divided by minus 4 plus c. And of course, you could write that as 1 over z to the positive 4 power. And so this could be written as minus 1 over 4 times z to the 4th power plus c. Again, it's the exact same thing. It doesn't matter as long as you know how to integrate it. All right, and here's some 3 nice little examples of how to illustrate to how you integrate x to some power n. That's how we do that. That was lesson 2. on to lesson 3. In this case, we're going to show you how to integrate a polynomial. So here we kind of combined what we've learned in the first couple of lessons. And then there's something in addition here. So what do we do when we have, for example, two terms that are added together, forming a polynomial? Well, it turns out we can actually rewrite that as two integrals separated like that. So ax to the n power times dx plus the integral of bx to the n power times dx. So we can actually separate each term into its own separate integral. And then, applying the rule that we learned before, we can actually take the constants, assuming a and b are constants, and move them outside integral sign. So this is equal to a times the integral of x to the n dx plus b times the integral of x to the m dx. Notice that n and m just simply imply that they don't have to be the same number. They can be two different numbers. And now we can apply the rule that we learned before. So we can say that this is equal to a times x to the n plus 1. We add 1 to the exponent, divide by the new exponent, n plus 1. And then we add a constant of integration. We'll call it c1 as a constant of integration of the first integration. And then we do the same to the second one. So plus b times x to the m plus 1. We add 1 to the exponent and then divide by the new exponent, m plus 1. And then we also add a constant of integration, we'll call it c2, for that integral. And then you can add c1 and c2 together because they're just any arbitrary constants. Add them together and simply say there's a constant at the end. So we can then write this as a times x to n plus 1 exponent divided by n plus 1 plus b x to the m plus 1 over the new exponent m plus 1 plus a constant of integration, and that's the integral of our polynomial like that. So we can see that what you can do is you can separate these, write a separate integral for each term in the polynomial, then move your constants outside integral sign, and then use the power rule here. So to illustrate that, here's a couple examples. Let's go ahead and do that. So first of all, we can say this is equal to separating that into two integrals and moving the constants out. So this is 3 times the integral of x to the third power dx plus 4 times the integral of x squared dx. So we first separated the two terms in the polynomial as two separate integrals, and we move the constants forward outside the integral sign. Now we can go ahead and integrate. So this is equal to 3x to the fourth power divided by 4 plus the constant of integration plus 4x cubed over 3 plus the constant of integration. Added the two constants together, that becomes plus c, and that's the integral of that particular polynomial. And then for another example, doesn't matter the negative signs there. So this is equal to minus 2 times the integral of x squared dx plus 5 times the integral of x dx and minus 3 times the integral of dx. And then we know how to integrate each one of those separately. So this becomes minus 2x cubed over 3 plus 5x squared over 2 minus 3x to the first power over 1, which we don't have to write. And don't forget the constant of integration, which is really the sum of the three constants we got from each of the three integrals. And that's how you integrate a polynomial. How to integrate, in this time we're going to integrate a very interesting type of integral. It's called the form 1 over x. And here's the example. The integral of 1 over x dx is, and of course I already gave you the answer, the natural log of x plus c. You say, wow, where did that come from? Well, without going into details, let's try to do this with the old power rule. If we say integrate 1 over x dx, and you say, okay, we can write this as the integral of x to the minus 1 dx. And if I use the normal power rule, we're going to add 1 to the exponent, divide by the new exponent. So you say, well, this is equal to x to the minus 1 plus 1 over the new exponent, minus 1 plus 1 plus c. And this becomes x to the 0 power divided by 0 plus c. And so, well, wait a minute. Divide by 0, that means undefined, so there's no integral. And it turns out, yes, there is. The integral of that is equal to the natural log of x plus c. So never try this methodology on trying to solve for the integral of a 1 over x form. All right, now that you know that this is the proper answer to the integral of 1 over x dx, let's illustrate that by using some examples like that. Well, first of all, remember that if there's a constant other than 1 there, we can move it outside the integral sign. So this is equal to minus 5 times the integral of 1 over z dz. And then we use the rule that we learned over here. So this is equal to minus 5 times the natural log of z plus a constant of integration. Notice that I put absolute value signs around z just like I did here because, of course, we cannot take the natural log of a negative number. So that's why we safeguard ourselves and say it can only be the positive value of whatever that number is. And then here we have an example like that. First of all, we take 1 over 7 out of the integral sign. And I wanted to write 7, not z. So let's correct that. So 1 over 7 times the integral of 1 over y dy. And then you can see that this is the exact same form that we have over here. So this then becomes 1 over 7 times the natural log of y plus a constant of integration. So those are fairly straightforward. Just remember, you can't use the old power rule. You have to say that the integral of the form 1 over x dx is simply the natural log of x plus c. And don't forget the absolute value signs. And that's how you do that. Here we're going to integrate the form e to the x. And actually, this is the easiest integral in the entire set of integrals, because the integral of e to the x dx is simply e to the x. So does that mean that the derivative of e to the x is e to the x? And you are absolutely correct. Of course, don't forget the constant of integration. Now, things will get a little bit more difficult when we talk about e to the x. For example, what do we do when we have e to the ax dx? And the answer is that is equal to 1 over a times e to the x plus c. And if we have a constant in front, of course, we have to move that outside integral sign. So we're going to multiply this 1 over a times b, and it will be b over a times e to the x plus c. So that's the general rule, the general concept of how we integrate e to the x. And to illustrate that, we have some simple examples. And just like I said, there are some things that are a little bit more complicated for which we need other integration techniques. And when we get to that, that will be the next lesson. The first one there would be integration by substitution. We'll see some more complicated cases of the e to the x form. But when they're simple like this is how you do that. So on the first one, e to the 2x dx, if we integrate, we get 1 over 2 e to the 2x plus a constant of integration. So just like if this was an a, it's 1 over a. If it's a 2, it's 1 over 2. If it's a 5, e to the 5x dx, that is equal to 1 over 5 e to the 5x plus a constant of integration. And finally, even if it's a negative exponent, the rules is exactly the same. It's 1 over minus 2 e to the minus 2x plus a constant of integration. So you can see that these are very easy integrals. They will get a little bit more complicated, but for that we'll need to use some other rules. We'll get to that later. If you're wondering why that is so, let me give you a little hint. Let's take this example again. Bring it over here. And let's say we have the integral of e to the 2x dx. Well, to integrate that, we have to have the proper differential. And the differential of 2x is 2 dx, and we're missing a 2 there. So what we want to do is we want to multiply this times 2. But of course, if we multiply times 2 to keep everything the same, we also have to divide by 2. So we go 1 over 2. And this is the differential of e to the 2x. And so therefore, when we integrate and the differential drops out, we get 1/2 e to the 2x plus a constant of integration. And so you'll see in the next lesson, when we start integrating using a special technique called substitution, you'll see how it's necessary to have the proper differential in order to integrate. So just in case you're wondering where did that 1/2 come from, or that 1/5, or that 1 over negative 2, you'll see that in the next lesson. But in the meanwhile, just simply memorize that. That's how you do it. And you're good, at least for this form of the e raised to the x power type of integration. All right. On to the next lesson.